Okay, in the final set for Chapter 5, we're going to look at functions and modelling, which is another way of saying we're going to look at real-life applications of functions and how we can use them to help us solve problems. So in this first question here, we've got some information about a book club that has a membership fee of $60, and each book purchased is $10. We need to construct a cost function that can be used to determine the cost of different numbers of books and then sketch its graph. So there's a few pieces of information in here which is going to be useful to us, and I'm going to underline them. We've got oops, not down there. I want to underline the $60 for the membership fee, the $10 for the each book. Now, what it asks us to do is to construct a cost function. A cost function indicates that we need to be able to calculate the cost of somebody joining and purchasing any number of books. So first of all, what I'm going to do is I'm going to work out what my variable will be. Obviously, the only thing that can change in the question is the number of books purchased. The $60 membership fee is going to be a standard $60 that anyone who joins pays. So everyone who joins has paid a minimum of $60. So therefore, my rule is going to be 60, which is a constant, plus however many books people buy. And books are charged at $10 per book. Alright, now I'm going to use N to symbolize the number of books bought. Now, when I write this in function notation, I'm going to write it using a similar method to f bracket x, but I'm going to use letters that indicate that it's from the real world question. So I'm going to say it's a function showing cost using n as the variable. So again, I have 60, which is the membership fee, plus 10 times the number of books bought, is equal to the cost using n, which stood for the number of books, as the variable. So I have my cost function constructed now, and the next question asks me to graph it. So here I've drawn my axes that I'm going to use to graph the cost function. Notice that I've labelled the axes. I've labelled the y-axis as the c, which shows the cost, and the x-axis as the n, which showed the number of books bought, because this is our independent variable. Everybody could choose to buy different numbers of books. So now it's asked us to graph the information. So the first one, actually I haven't put the numbers onto the graph, which I'll do now. So there's my scale. It goes from 1 to 6 books, and it goes from $20 to $120. So now the first amount, if you bought 0 books, would be 10 times 0 plus 60. So 0 books would be right on this 60 mark here. 1 book would be right on $70 here. 2 books would be on $80. 3 books would be on $90. 4 books would be on 100, excuse the poor line. 5 books would be on 110, and 6 books, is that right? 5 books would be on 110, and 6 books should be on 120. Now, we should all know that to calculate any of these, we could just substitute into the cost function. So, for instance, 5 books would look like this. C at 5 equals 60 plus 10 bracket 5. So therefore C at 5 equals 60 plus 50, which equals 110 there, which if you look at the graph, this is what the information showed us. 5 books was down here, and go up to the green dot above that, and you come across, you get 110. It's not a very good graph, but I've just drawn it by hand quickly. So there you have our cost function. Now the other important information that we can pull from this is the domain. You can clearly see here that the domain has to be greater than 0, so x has to be bigger than 0, but you might also notice that the dots are discrete numbers. Now this particular question has a rather specific thing we're going to count, which is numbers of books. Now we know it's not possible to buy half books or decimals of books, so therefore another way of writing this domain would be to say that x was a subset of the natural numbers, which we know are not negative and not fractions, including union the set of 0. So it starts at 0 and then moves up in whole number lots. And if you wanting to find the range of it, you could straight away see that the y has a range of a subset of natural numbers also, including when x is greater than 60. Because you can see here at the start that it doesn't go any lower than 60. To go lower than 60, you'd have to have a negative x value, which is impossible because it's numbers of books. To recap, we're looking at practical situations here, so our cost function has to be part of what we read in the question. The graph has to show what we're going to see in real life. We only need to show the first quadrant in most real life situations because the thing we're measuring is going to be mostly positive, but you want to read the question and make sure you get that information out of there. The last thing is the domain has to reflect the fact that it's relating to a real world situation. So in this case, we can't have negative numbers of books, therefore the domain has to be positive numbers only. Now in this question, this is a fairly classic methods question that involves a number of steps. So I'm going to talk you through how to do this one, and then you can hopefully apply that to other information or the other questions you'll come across in the future. So we'll go through it. A householder has 6 laying hens and wishes to construct a rectangular enclosure to provide a maximum area for the hens using a 12-metre length of fencing wire. So that the most they can use is 12 metres. They can't use any more. Construct a function that will give the area of the enclosure A, so it's told you a variable it wants or a letter it wants you to use, in terms of its length L. And you know it's a funny L, but you can use any L you like. By sketching a graph, find the maximum area that can be fenced. So there's a number of things in here that are going to be important for us. We're constructing a rectangular enclosure. We're wanting to find the maximum area using 12 metres of length. We want to construct a function that will give the area in A in terms of L, and then sketch a graph. Okay, so the first thing I'm going to show you is how to construct the function. And the first thing you want to do is to define a variable. So it's told us in here that the variable it wants us to use is length. So I'm going to first start by drawing a rectangle. I'm going to put L on here, and I'm going to put W on there for width. So you can clearly see here that the 12 metre length, the 12 metres in total, has to be made up of 2 L's plus 2 W's equals 12. So that's the biggest or the most amount of wire we can use. So you can see here that there's a common factor of 2 in each of those terms, which means we can simplify it down to L plus W equals 6, which makes sense if you think about it. Half of the length of 12 has to be the same as one of each side, length and width. Alright, so there is our first one. Now, what I'd want to do is to then construct an area formula. Now we know that area is length times width. Okay, now up here in the question it says to construct a function that will give the area in terms of length. Now what this means is that the only variable that we can use has to be length. So what I'm going to do is I'm going to take the this function here and I'm going to rearrange it to become W equals. So what it's going to look like is W equals 6 minus L. Now this in turn will be substituted into the area formula in place of W. So the new function is going to look like this. Area equals L times 6 minus L. Now you can see here that the new function has got the only variable in there is L. Now to put this back into more of function notation terms, I'm going to rewrite the A side. So I'm going to say the function A using L as the variable, and I'm also going to expand out these brackets here, so it's going to become 6L minus L squared. So in function notation we have area using L as the variable is equal to 6 times L minus L squared. Now you can see here that from our function knowledge, or sorry, from our quadratic knowledge, we can see it's a negative quadratic, which means it has the rough shape of this. We can see that the only variable being used is going to be L, the length. Now the reason this is so important is because when we want to solve a function, we can only solve a function when there's one variable. which you'll know from your simultaneous equations. If we have more than one variable, we need more than one equation to solve it. So we have here one equation, which means we only can use one variable, which is why we've gone through all these steps to produce this equation here. So this is the function that will give the area of the enclosure. Let's look on the next step. It says, by sketching a graph, find the maximum area that can be fenced. So I've drawn the rough shape here, the upside down quadratic here. You could do that. You could sketch it all by hand, or you could just chuck this 6l minus l squared into your CAS and it will graph it for you. Remember when doing this in your CAS that in place of the variable, the calculator needs to have x. So you need to put in x instead of l, but remember that when you write it down and answer your question, you'll still be using l. So what I'll do now is I'm going to chuck it into Desmos and we'll have a look at what it looks like. So here's the graph of the function. I've just put it into Desmos, and you can do it in your CAS calculator, or you can solve it using factorized method. In fact, the previous step 2 before we finished it was factorized. So you can see here that the factors are 0 and 6, which is what happens down here on the graph. Now what this means is that the area function, so the area starts at length equals 0, in which case the area was also 0, and goes up, then decreases until it reaches, again, length equals 6, in which case the area is also 0, which makes sense because if you have a maximum of 12 meters of wire and both lengths are 6, that means there can be no width because the 12 meters is taken up with both of the lengths. So this intercept and the first intercept give you 0 areas, which is pointless. We don't want that. We want the maximum area. So the maximum area is where the tip of the quadratic is. And you can clearly see here from the coordinate point that when the area is at its highest, which is 9 meters squared, that the length is 3. Now what this means is that if the length is 3, you can see here that if I draw these two lengths of 3, I've used up 6 meters of wire, which means I have another 6, which means that the two sides, the widths, are also going to be 3, which means that the most efficient use of the wire is to make a square. Now, the other thing we can talk about in terms of this graph and how to use it is the domain. Now, the domain in modeling using functions has to be the real thing, or the real world. You notice that the quadratic continues below the x-axis at both ends, but we know that the area of shapes has to be a positive area. Therefore, the domain will have to go from start at 0, so x is a subset of 0 to 6, because that's where the intercept is. And we know that if we go outside that interval, that the area drops below 0, which is a negative area. And if you want to talk about the range, we can go from 0 to 9 using the minimum area and the maximum area. So there you have it. This is all the way to step through a real-world problem called a modelling problem. These questions pop up fairly regularly in Year 11 and in Year 12, and the assessors are looking for you to think through a problem one step at a time. So just to recap, what you need to do first of all is to write yourself an equation that relates the information in the question together, then go through the next equation that they want you to work with. And what I've done here is I've looked in the question and it says in terms of length. So this is how it tells you that the variable L is the only one it wants in there. And then you just go through until you end up answering the question. So I've graphed it often, or sometimes they won't ask you to graph it. Sometimes they'll ask you to go from this form and do the rest of it by hand. However, keep in mind that the easiest way to check your answers is to graph them on the calculator to make sure that you're doing the right things. Alright, so hopefully that helps. If you have any troubles, feel free to contact me.